Alright, today I will be going through my solution for the calculus senior project, which was that we have a sheet of paper that's 6 units wide and 25 units long. Place so the short side is facing you. Hold the lower right corner over to touch the left side. So we have to minimize the length of that crease when we fold the corner over. So let me start with what we have. So we have a piece of paper that's 6 by 25. And what we want to do is fold it so that this corner right here is touching the left side. So it's still 6 and 25 on the side. And we have these little triangles. This little area represents where this triangle would be taking up in that piece of paper. So we'll start labeling our triangle. I'm going to label this part of the triangle X. I'm going to label the crease length, which is the hypotenuse of the triangle, as L. This area Y. And right here, from this point to here, as Z. So we know if this is 6, then right here is going to be 6 minus Y. If this is also Y. These two areas would be equal in theory, because this will also be X. So then we know that this length is 25 minus X. And over here, from here to here, is 25 minus Z. So it looks fairly complicated. So to start, we want to figure out what at least one of these variables means. So we know for this triangle right here, we can basically use Pythagorean theorem to figure this out. So we have z squared plus 6 minus y squared equals y squared. And basically what we're going to do here is solve for z. So z squared is still just z squared. And this, when you multiply that out, do FOIL or whatever, you get y squared minus 12x plus 36 equals y squared. So then isolate your variables, move things to the other side. Z squared ends up equaling y squared minus y squared plus 12x minus 36. Those two y squareds cancel out, so you have z squared equals 12x minus 36. Then take the square root of that. Z equals the square root of 12x minus 36. So that's, in terms of this equation, that's what z would be equal to. So now, what we're going to want to do is plug that into a bigger equation that we know. So we know we can find the area of what this whole paper would be. So that would be area equals 6 times 25, which is 150 units squared. So it starts to get really complicated from here on. So what we basically know is that we have, for the area of this whole rectangle, we have the area of a rhombus, the area of these two triangles, because to add it up to make it the whole rectangle, these two triangles and this triangle. So what we're going to do, basically plug in the area formulas for those. So for the first triangle, we're going to substitute the square root of 12x minus 36 in for the z. So we have 1/2 6 minus y z plus 2 times 1/2 y times x plus, for the area of the rhombus, 1/2 25 minus x plus 25 minus z times 6. So we have the area of the small triangle, the area of these two triangles in the middle, and the area of the rhombus. So now we're going to start simplifying that. Substitute the root 12x minus 36 in for z, 6 minus y, root 12x minus 36 plus 2. Well, basically that's just y times x, because the 2 times 1/2 is just 1, plus 1/2 25 minus x plus 25 minus square root of 12x minus 36 times 6. So then we start simplifying this, multiply the 1/2 and the 6. You end up with having, alright, 6 times 1/2 is 3, times 1/2 is basically just, well, we'll leave that 1/2 like that. 6 times 1/2, so 1/2, 6 minus y, root 12x minus 36, plus y times x. Then we have 3, because the 1/2 times 6 is 3, 25 minus x plus 25 minus root 12x minus 36. So then multiply those out, you get, we'll multiply this now, these variables, so you get 3 minus 1/2 y times 12x minus 36 plus yx. Now we multiply these out, 150 minus 3x minus 3 12x minus 36. So that looks about right. So then we'll multiply these out, so you'll get 3 root 12x minus 36 minus 1/2 y 12x minus 36 plus yx plus 150 minus 3x minus 3 root 12x minus 36. The 3 12x minus 36 is positive here and negative here, so these will cancel out, which leaves us with negative 1/2 y root 12x minus 36 plus yx plus 150 minus 3x. So now we're basically gonna move that 150 to the other side, which gives us, oh no, actually we're not going to move that 150 to the other side. Forget I said that. So we know that the area of the whole rectangle is 150 units. So now we basically set what this area formula that we figured out here, the simplified formula, equal to that to solve for our variables. We're going to end up solving for x, and you'll see that in a minute. So 150 equals negative 1/2 y root 12x minus 36 plus yx plus 150 minus 3x. So you see here that we have 150 over here and 150 over here. So those are going to cancel out, making this side to be 0, equals negative 1/2 y root 12x minus 36 plus yx minus 3x. So, as you can see here, you can group these together, and they both have an x in both of these variables, so you can take an x out, you can factor an x out of that. So 0 equals negative 1/2 y root 12x minus 36 plus x times y minus 3. So that's what we have so far. And then from here, you can move the negative 1/2 times 1/2 y times 12y to the negative 36 to the other side. Hold on a sec, let me just check to see if I label these wrong at all. Oh yeah, at the top up here, I forgot, I didn't want to solve for the x here. That's not supposed to say x, that's supposed to be a y. So everywhere that I wrote root 12 x to the negative 36, this is supposed to be actually root 12 y to the negative 36. So let me correct that in what I have right here. Yeah, that kind of threw me off for a second. I didn't know what I was doing for a second. Alright, so now that I've sorted that out, so we got 1/2 y, 12y minus 36 equals y minus 3 times x. Then solve for x. X ends up equaling y, 12y minus 36 over 2y minus 3. So basically that's simple. You divide by the y minus 3, so then you have the 1 times y times 12y minus 36 over 2, because it's 1/2, y minus 3. And that's what x is. So now it gets even more complicated. Let me get to another piece of paper. So now we want to start looking for that crease length, which I labeled as L earlier. So we know that L is going to equal, based on this diagram, we know that L is going to end up equaling the square root of x squared plus y squared, because that's Pythagorean theorem. So basically, since we know that x is equal to y times root 12 y minus 36 over 2 times y minus 3, we can sub that in there. So L is going to equal y squared plus y 12 y minus 36 over 2 y minus 3 squared. So if you end up squaring that out, doing out the math of the exponents, you get y squared plus y squared times 12y minus 36, because the square, 2 to the second power times the square root cancels out the square root, making it just to the first power, over 4, because 2 squared is 4, times y minus 3 squared. So then that all ends up equaling y squared plus, so basically what you can do is you can factor the 12 out of that, out of this equation, so you end up having y minus 3 here, over 4 times y minus 3. Those will cancel out, which leaves you with the square root of y squared plus 12y squared over 4. Oh, actually that doesn't completely cancel out. It cancels out that. When you cancel that out, it doesn't completely cancel out the y minus 3. Since it's squared, it cancels out one of those, so it leaves you with another y minus 3 to the first power underneath. So now what you can do is 12 divided by 4. It's going to leave you with 3y squared over y minus 3. So basically, the crease length is going to equal the square root of y squared plus 3y squared over y minus 3. So now, in order to find all of that, you're going to have to find the derivative of that. So L prime equals, it's going to involve chain rule, and quotient rule, I believe. So what you want to do is, you know that y squared, the square root of y squared plus 3y squared over y minus 3 is basically the same thing as saying y squared plus 3y squared over y minus 3 to the 1/2 power. And when you use that's basically going to involve the exponents rule, the power rule, when you move the exponent down to the front. So that's going to be 1/2 times everything that's inside, which is y squared plus 3y squared over y minus 3. And then you subtract 1 from the exponent that you have. So that's going to leave to the negative 1/2. Then, for the rest of it, you're going to go on to find the derivative of what's inside. So, again, with the power rule, come down 2y, leaves a 1 at the top, you don't have to write that, plus, I ended up getting, let's see, bring the 2 down, you get 6y, this is where quotient rule comes in, 6y times what's on the bottom, y minus 3, minus f prime, which is basically, well, minus f times g prime, which is just 1 because the derivative of y minus 3 is 1, all over g squared. So my f was 3y squared and my g was y minus 3. So f prime was 6y, g was y minus 3. That was just f, and then this is my g prime. So then the next step is simplify this derivative. I'll do that on this next line. So L prime equals, you end up having 2y plus, let me see, you end up having 2y plus 3y squared minus 18y over y minus 3 squared. That's from multiplying these out and simplifying and then that stuff, all over 2 times y squared plus 3y squared over y minus 3, because it's to the negative 1/2, and over 2, so the 2 comes down because it's 1/2, and the negative 1/2 puts it on the bottom to the square root. So then, simplifying that even further, you are left with 2y plus y times 3y minus 18, because over here you can factor out a y, over y minus 3 squared, over 2 square root of y squared plus 3y squared over y minus 3. And then on top of that, you can factor out another y, because 2y and a y here. So you're left with y times 2 plus 3y minus 18 over y minus 3 squared. That's on the numerator. In the denominator, you still have 2 square root of y squared plus 3y squared over y minus 3. So then, from that point on, we're gonna be using the applied extrema methods. So you set that derivative equal to 0. So basically, what you can do is just set the numerator equal to 0, and then solve for the variable y. So when you do that, you get y times 2 plus 3y minus 18 over y minus 3 squared equals 0. So then, in that case, the y over here, y would just equal 0 as one of them. One possibility is y equals 0 because it's multiply times y, one factor. So then you solve for the what's on the inside, set that equal to 0. So in that case, what you want to do, so then you have, after that you have 3y minus 18, y minus 3 squared. Subtract 2 from both sides, so you have negative 2 on the other side. And then next, you would multiply both sides by y minus 3 squared. So I'm going to do that over here now. 3y minus 18 equals negative 2 times y minus 3 squared. And then just square these, so we're just going to basically be simplifying from here on out. Equals negative 2 y squared minus 6x plus 9. Then multiply the 2 throughout it. So you get 3y minus 18 equals negative 2y squared plus 12x minus 18. And then just subtract the 3y from both sides and the 18 from both sides, so you end up having 0 equals negative 2y squared plus 9y. Then you can factor out a y here, so you have negative 2y plus 9. And then again, in this case, the factor y would be equal to 0, and then you continue setting what's on the inside of these parentheses to 0. So negative 2y plus 9 equals 0. Negative 2y equals negative 9. So that leaves y as being 9 halves. And since we know that a section of a piece of paper has to be some length, it can't be equal to 0. So that leaves the only possibility is y being 9 halves. So that prevents you from having to go through the trouble of figuring out which one's the minima, which one's the maxima, because the only possibility is that 9 halves, which would be, in fact, the minimum, because it can't be 0 units long. So from there on, you want to go back to that original area equation where 150 equals the simplest. You want to go back to the simplest form of that area equation that you got, which I'll show you is this one. And you can plug in the 9 halves for y in all of that, and then you solve for x. So we're going to do that right here. So 150 equals negative 1 half times 9 halves, because remember that was a y, times the square root of 12, 9 halves, minus 36, plus 9 halves x, plus 150 minus 3x. So that's what you end up having in that area equation when you substitute the 9 halves for y. So the 150s cancel out because subtract them from both sides. So that leaves you with having about negative 2.25 times the square root of 18 plus 9 halves x minus 3x. So then move this over here, basically plus 2.25 root 18 to both sides. And you can simplify 2.25, which is what I got in my calculator, but 2.25 is the same as saying 9/4. So 9/4 times root 18 equals 9 halves x minus 3x is equal to 3 halves x. So then you do, so then in here we know that 18 is 9 times 2, so 9, you can take the square root of 9, which is 3, so basically 9/4 times 3 root 2 is what you end up simplifying from root 18. equals 3/2 x. So then multiply it out, you end up getting 6 3/4 root 2 equals 3/2 x. And 6 3/4 root 2 is, then divide by 3/2, both sides divided by 3/2, leaves you with 9/2 root 2 to equal x. And then, which is basically x ends up equaling about 6.36 units. Alright, so we know what x is and we know what y is. X is 6.36 and y is 9/2. So then all we have to do is solve for the length of the crease. And I'll do that in this space right here. So we'll use Pythagorean theorem because the crease is from the triangle. So we'll have L squared equals x squared plus y squared. So then in terms of that, the x is 6.36 units, so 6.36 squared plus 9/2 squared, which ends up equaling about 40.4496 plus 20.25, which equals 60.6996. So since that's L squared, we just want L. Take the square root of that. So L ends up equaling 7.79 units. And that is your solution. And so to recap, folding the paper so the right corner is touching the left corner, you need to go through and find equations so that you can solve for some of the variables, because you basically in the end you want to get it down to one variable. So we started with the Pythagorean theorem here, solved for z, and we got root 12y minus 36. Sorry for saying x at the beginning, I got myself confused. It's root 12y minus 36. Then we know the area is of the whole sheet of paper is 150 units, and we can break that down into each of the geometric shapes. So we got the rhombus, two triangles, two of these equal triangles actually, and this little triangle. So we have 1/2 base times height, 1/2 base times height twice for those two triangles, and then the rhombus area formula. And we simplify that till we got negative 1/2 y root 12y minus 36 plus yx plus 150 minus 3x. Set that equal to the area that we found, 150, and solve for x. So x, we got y is root 12 equals x equals y root 12y minus 36 over 2 times 1 minus 3. Then after that, we went on to find the crease length formula by using Pythagorean theorem, and we solved for that, and we took the derivative of that. Then we used that to solve for y by setting it equal to 0, and using everything else that we already knew, plugging in those things that we found the variables as being. So we used that, and then after that, since we got the two possibilities is y equals 0 or y equals 9/2. So since the crease length, since the area of, since the length of one of the sides can't be 0 in the triangle, that leaves it as having to be 9/2, which is the minimum length of that side. And we use that to solve for x. So we plug the y being 9/2 back into that area equation, solve for x, and then we use that the crease length equation to find the length of the crease. So we got the minimum length of the crease as being 7.79 units. Sorry if this was a little choppy, but I wanted to make it a video because I felt like that'd be the easiest way for me to explain it. So thanks, Mr. Corbett. Hope you enjoy this video. I'll be seeing you around.